Okay, hello everyone. My name is Ramona Irie. I work at NAVFAC Exwick in Port Hueneme, California, and I would like to thank you for attending the Open Environmental Restoration Resource Webinar on PFAS Analytical Methods. This topic has been requested in the past, and we are happy to bring it to you today. This presentation is being recorded, and if you visit navfac.mil/go/ERB, you will find links to all of the available past OER2 webinar videos under the training portion of the site. Next slide. Before we begin the presentation, I want to emphasize the following important disclaimer. This seminar is intended to be informational and does not indicate endorsement of a particular product or technology by the Department of Defense or NAVFAC Exwick. Although every attempt is made to provide the most accurate information, there is no guarantee that any technology or product will be suitable for your site. And as always, participation on the webinar is voluntary. Next slide. Our speaker today is Janice Willey. Janice is a senior chemist for DoD Labs Quality and Accreditation Office and the chair of the DoD's Environmental Data Quality Work Group, Chemicals of Emerging Concern Subgroup. As the subject matter expert on sampling and analysis for PFAS for the DoD, she chairs a number of PFAS working groups and is involved in the DoD's PFAS method development and validation initiatives meant to address the DoD's current and future PFAS analytical needs. Next slide. Before our speaker begins the presentation, I would like to invite Kim Parker-Brown from NAVFAC headquarters to say a few words about the OER2 webinars.
Okay. Thank you, Ramona. And hello all. As Ramona mentioned, I'm Kim Parker-Brown. I'm an Environmental Restoration Program Manager with NAVFAC headquarters. And we at NAVFAC appreciate your participation in the Open Environmental Restoration, or the OER2 webinar series. We have been providing this webinar series since 2014 and look forward to be providing another informative topic for the environmental community today. This webinar series is for our RPMs, our RTMs, contractors, and any others who support the Department of Navy Environmental Restoration Program. Our goal is that the series will provide a venue for two-way communication from both reaching out to and obtaining feedback from the community members. And the emphasis of the webinar series is to share information openly and to promote innovations among the environmental community. So this can be done via our Navy policies, our guidance, our tools, our technologies, practices, initiatives, or even our lessons learned. We'd also like you to know that feedback from our environmental community members is key to sustaining our webinar series. So we want you to please feel free to recommend topics or to volunteer as presenters. And any topic which is considered should be relevant to the ERP and should not contain any marketing materials. If your topic is selected, you will be working with a Navy champion, and the community member may present the topic possibly with a Navy POC. So today's webinar, which, as you had heard, which is on our PFAS analytical methods, is a very important topic for the ERP, in that currently the Navy is completing our base-wide PAs and SIs on our Navy installations. And these methods are key in testing and analyzing for these key compounds. This webinar is being presented. As you see here, the objectives are to provide information on the methods that are available, along with providing an understanding of how they apply to our DoD policy and guidance. The webinar will also provide future analytical methods and their implication on future policy. Please feel free, you can feel free to ask questions, via the chat about the methods, but note that this webinar is not to address any policy questions at this time, as in some cases, DoD is still finalizing policy on implementation of some of our draft methods. So just wanted to let folks know that we will not be addressing any policy questions, but you can feel free to ask anything about any other methods. So with that, I'm going to pass it over to today's presenter, Ms. Janice Willie. Janice?
Oh, hold on one second. She might have accidentally got muted.
Me now?
Hey, Janice.
All right, can you hear me now?
Yes, we can.
There we go.
Oh, there's
Yeah,
Janice.
I'm glad I asked if you could hear me, and I didn't get a response before I just kind of dove into everything. So, okay, first I want to thank Kim and Ramona for this opportunity to talk with everyone today about the PFAS analytical methods. I understand it was a very popular request for a webinar. So let's just go ahead and get started. We'll start with the methods you probably know best, the drinking water methods in EPA 537.1. This method, or earlier versions of it, has been really the workhorse for the drinking water analysis for years. It's applicable to drinking water source testing only and includes 18 PFAS, 4 of which are not included in the other drinking water method, method 533. We currently have 20 DoD ELAP accredited laboratories accredited for EPA 537.1, which you can find by searching the DoD ELAP accreditation database on the DENX EDQW website by entering 537.1 in the method drop-down box. As far as policies and NAVFAC guidance are concerned, this method is required for the analysis of drinking water. So this should be the method you are currently using for drinking water analysis. Next slide. Next up, we have the other drinking water method, EPA 533, again, only applicable to drinking water source sampling. It analyzes a list of 25 PFAS, which overlaps the list of EPA 537 by 14 analytes. So that means there are 11 additional PFAS that are unique to this method that are not included in 537.1. You will note that a few of these are the ones commonly associated with ATROVOF concentrates. Currently, there are 11 DoD ELAP laboratories accredited for this method. And again, you can search the accreditation database, but this time select EPA 533 in the method drop-down box. Currently, there are no DoD policies or NAVFAC guidance requiring the use of this method. However, that may change very shortly. So why do I say that? Let's go to the next slide. Oh, because of the 5th Unregulated Contaminant Monitoring Rule, UCMR 5. It was finalized and published in the Federal Register on January 29th of this year. It requires the analysis of lithium by EPA 200.7 with a minimal reporting limit or MRL of 9 ppb. That's the only analyte that's not a PFAS in this rule. 29 PFAS are also included in this rule. There are 4 PFAS that are required to be sampled and analyzed in accordance with EPA 537.1. If you go back to the 5th slide on this presentation, you will see that these are the 4 PFAS that are unique to this method, i.e. not in EPA 533. Their MRLs range from 5 to 8 ppt. So 4 PFAS by 537.1 are required. Simple math leaves you with 25 PFAS. Those 25 PFAS are required to be sampled and analyzed using EPA 533. Their MRLs range from 2 to 20 ppt. Currently, 24 laboratories are EPA approved to perform all 3 analyses, and 11 additional labs are accredited for 1 or 2 of these methods, meaning, for example, a laboratory may be accredited for 200.7 and 533 only. You can find a wealth of information on UCMR 5, including a link to the list of EPA-approved labs at the link provided on this slide. Next slide. Here I just provide you with the list of PFAS under UCMR 5 and the respective MRL. With the finalization of this rule, you could easily see policy transitioning from requiring the use of EPA 537.1 only to utilizing this two-method schematic for drinking water sampling in the future. Next slide, please. Moving away from drinking water, we need to very briefly talk about SW846 PFAS method. There are two SW846 methods published for PFAS, one for sample preparation, method 3512, and one for analysis, 8327. These methods are applicable to non-potable aqueous samples only, and their analyte list includes 24 PFAS. These 24 PFAS do not include all the analytes included in EPA 537.1 or in EPA 533. It uses a quasi-direct injection method. What I mean by this is a solvent is added to the sample and the sample is analyzed. So there are no processes in the method to eliminate potential matrix interferences. As far as analysis is concerned, external calibration quantitation is used, which does not account for biases associated with either sample preparation or sample analysis. Due to issues associated with the preparation and analytical processes included in these methods, the DoD considers this method to be a screening method and therefore cannot be used for the collection of definitive data. Since it is identified as a screening method by the DoD, it does not fall under the DoD ELAP accreditation program, so laboratories cannot get accredited for it under their DoD ELAP accreditation. Next slide. In April of this year, the EPA Office of Water published a draft method, EPA Draft Method 1621, a screening method for the determination of absorbable organic fluorine, AOF, in aqueous matrices by combustion ion chromatography, or CIC. This method has been single lab validated for organofluorine content in wastewaters. It estimates an aggregate concentration of organofluorine content, which includes PFAS, which is why I'm talking to you about it today, as well as non-PFAS fluorinated compounds such as pesticides and pharmaceuticals. The method does not include a means of distinguishing between PFAS and non-PFAS compounds, and also does not include all potential PFAS in the calculation due to the limitations associated with the sample prep technique that is used. Because of these limitations, results from this method are not indicative of a so-called total PFAS determination. The accuracy of this method is also hampered by a number of interferences. Because of all these limitations, EPA has declared this method to be a screening method only, and DoD absolutely agrees with this. As this is like the other draft methods that EPA has published, EPA 1633, the EPA encourages the use of the method. However, there's one big difference. While the EPA currently encourages the use of method 1633 for compliance purposes, it does not currently endorse the use of this method for compliance purposes. And this method is currently not required for Clean Water Act compliance monitoring. Next slide, please. Next up, I want to briefly talk about a method that you may have heard a little bit about, but probably will not come into play at your facility. That's EPA's Other Test Method 45, or OTM 45. It is applicable to the emission sampling from stationary sources, not ambient air. So for instance, if someone says you should use OTM 45 for vapor intrusion, you should not. The method includes procedures for sample collection, preparation, and analysis of approximately 50 PFAS. It utilizes filters, impingers, and sorbent media. Collection using these media results in 4 discrete sample extracts per sample location. The method does state that non-targeted analysis can be performed on the resulting extracts. However, it does not provide a means of doing so. That analytical process is currently in development as a future method. This method is important to the DoD, especially right now. With the moratorium that is currently in place for the incineration of PFAS-laden materials, this method is one of the methods needed to thoroughly evaluate those thermal treatments. Next slide, please. Let's move on to all of the other matrices other than drinking water that you are asked to sample. before December 31st of last year, DoD policy and NAVFAC guidance required the use of methods that were compliant with Table B15 of the DoD's Quality Systems Manual, or QSM, for environmental laboratories. Table B15 and its associated quality tables, tables C4, C44 and C45, provide only quality control requirements, not a method. Since no method existed, these tables served as a baseline minimum quality control requirements that could be achieved by DoD ELAP accredited laboratories, and were what most of you use to help you fill out your method performance criteria and your UFP QAP worksheets for your projects. This table served the purpose of providing a list of minimum QC criteria that would ensure a defined level of uncertainty is achievable and decrease the level of interlaboratory variability until the time at which there's an appropriate method published that meets DoD's data quality needs. That method came in the form of the EPA Draft Method 1633. Next slide. Following the publication of the Draft Method 1633, the DoD issued a memorandum that required its use for all new contracts and task orders issued after December 31st of last year. This memo also encourages existing projects to require this method as well. Where can you find the requirements for this method? Well, that's not as simple as it used to be. DoD ELAP accreditation requirements for Method 1633 are found in the method itself and any and all errata sheets published by the EPA and the DoD QSM, current version 5.4, Table B24. Yes, there is a new table. Table B15 is not applicable to EPA 1633. You may be wondering if there's a new table, why do I have to look at the method and errata sheets for requirements? Well, you have to understand the goals of the table first. Next slide, please. Keeping the overarching goal of ensuring analysis by EPA 1633 meets DoD's data quality needs, we set out to be as consistent with the method requirements as possible. This helps to gain acceptance for use of our table. Since DoD partnered with the EPA in the development of this method, for the most part, the method meets DoD needs. Where this is not the case, it's due to either programmatic differences or the lack of requirements due to the fact that this method is currently in draft form. The table includes only requirements that are more stringent than the method or provides a requirement where the method did not provide one. This is the case, for example, for acceptance criteria for batch QC samples. So this means not all requirements are included in the table, as the table statement, the statement in the header of the table states, which I provided on this slide as well. For example, the table does not include any requirements for initial calibration. Does that mean there are no requirements for initial calibration? No, it means our labs must comply with the calibration requirements contained in the method. So when filling out UFP QAP worksheets, you will need all three documents, the method, the errata sheets, and the QSM. But to help you out in the future, my subgroup of the EDQW is developing some worksheet templates that will have all the required information populated from Table B24, the method, and the errata sheet. From there, your projects will be able to tailor them to your data quality objective. Next slide, please. So for some of the basics of the method, it was published in September of last year and is applicable to groundwater, surface water, wastewater, landfill leachates, soil, sediments, biosolids, and tissues. We validated single lab validated this method for all of those media. Its analyte includes a total of 40 PFAS. This list includes all of the analytes in EPA method 537.1, 533, and 8327, as well as 8 additional analytes. Next slide, please. On this slide, I know it's hard to read, but maybe you can utilize it after we send it to you, blow it up a little bit so you can see it better. I've provided you with a comparison of the analyte list from EPA 537.1, 533, and 1633. Next slide. Let's go over some more basics. There are media-specific sample preparation procedures included in the method for aqueous, solid, and tissue samples, and the method utilizes isotope dilution extraction and internal standard quantitation. It has been single lab validated by CERTA, thus the draft designation, and is currently undergoing multi-lab validation. Next, I want to give you some idea of what using this method instead of one compliant with Table B15 will mean to you. Next slide. Let's start with sample collection. There are few requirements in the method that are specific to sampling. For example, in-field composite equipment must use only HDPE tubing, and an integrated flow meter must be used to collect proportional composite samples. You probably already are meeting those requirements. Where Table B15 contained no requirements for sample containers and most projects defaulted to what the laboratory recommended and DoD guidance, this method specifies the size, type, and number of sample bottles to be used, as well as storage and shipping requirements. It also provides holding times that are based on a holding time study that was part of the single lab validation of this method. When you read the method, you'll find it provides 2 storage temperature options. Holding times are vary depending on the option selected and your analytes of interest. Projects are going to have to evaluate the options provided by the method and determine the appropriate storage temperature based on their project analyte list and maybe some other factors as well. The key point is you cannot default to what the laboratory states as their holding times and storage requirements with this method, like you've done in the past. Next slide. Here I provide you with a summary of the method requirements for collection. In the past, most laboratories defaulted to what the drinking water method with respect to the sample volumes needed for the analysis of aqueous samples which was 250 milliliters. This method utilizes 500 milliliter samples for aqueous samples, which is consistent with most organic methods. There is one exception, which is landfill leachates, which they tend to be a little bit nastier, which require 100 milliliters. It also states a second bottle of each sample should be collected. This bottle can be of a lesser volume for all aqueous samples except for landfill leachate, as that's already at 100 milliliters. This bottle is used to screen your samples for high concentrations of PFAS. In the past, laboratories took a small aliquot from the sample you sent them for screening purposes. EPA 1633 clearly states that any aliquot taken for screening must be taken from a bottle other than the one used for analysis. The sample must be protected from light. All samples must be protected from light at 0 to 6 degrees Celsius from the time of collection until received by the laboratory. Aqueous samples should be received in the laboratory within 48 hours from the time collected, and tissue samples should be received within 24 hours of collection. If longer transportation time is needed, tissue should be frozen prior to shipping, if possible, shipped on dry ice. Next slide. In the laboratory, that's where we have a couple thermal preservation options. There are 2 temperatures that samples are allowed to be stored at per the method, 0 to 6 degrees Celsius and less than or equal to negative 20 degrees Celsius. You'll see that here that samples can be stored for up to 90 days from collection at less than or equal to negative 20 degrees with only one exception. The exception is for solids. If NAVFAC is an important analyte, samples need to be prepared as soon as possible. For aqueous samples, the method allows for storage at 0 to 6 degrees C for up to 28 days, but notes the precursor degradation occurs after 7 days. So if this is a concern for your project, the new holding times would be seven days at 0 to 6 degrees Celsius. Solids and biosolids both can be stored for up to 90 days at between 0 to 6 degrees Celsius. However, again, if NAVFAC is an important analyte for solids, it should be prepared as soon as possible. Besides analyte lists with respect to aqueous samples, you want to consider any issues that you have encountered in the past with the laboratory with respect to holding time exceedances. For me, if a laboratory routinely misses holding times, or I know my samples will be sent to a laboratory during their busiest season, so summer, I would choose to default to the freezing option to allow for a 90-day hold. I can tell you most laboratories want to use the 0 to 6 degree storage because that's what they're used to having, and that's what they have the highest capacity for. This should not be a factor when deciding what your project requirements are, but you should make sure to select a laboratory with adequate freezer space if your project needs or wants to require samples to be frozen. Laboratory capacity should not determine project requirements. Project requirements should determine which laboratories can be used for your project. There's only one storage temperature option for sample extracts, 0 to 4 degrees C. All samples can be stored up to 90 days with two exceptions. If the ether sulfonates are important analytes for your project, aqueous samples have a 28-day hold time. If NFDHA is an important analyte for your project, again, salt samples have a 28-day hold time. Next slide. Another area that is different from Table B15 is sample preparation. Table B15 did not contain detailed sample prep procedures like EPA 1633 does. Like I stated earlier, aqueous samples should be screened prior to preparation using a second container. This is actually a really critical step. High concentration samples that undergo whole sample extraction as required by the method could contaminate not only the equipment in the laboratory, but other samples in the prep batch, potentially other sample batches to follow, and thereby result in a biased high quantitation. Bottom line, if you have no previous sampling results for a location showing low concentrations, be sure to send the extra bottle and have laboratories screen those samples. Once concentration history is established for a location, the need for screening can be based on that history. All samples undergo solid phase extraction and carbon cleanup steps, including AFFF and other high concentration samples. In the past, Table B15 exempted these samples from this requirement, allowing for basically a dilute and shoot scenario. This is not permitted by EPA Method 1633. When sample screening shows high concentrations, an aliquot of the sample is brought up to a final volume to match routine samples, so 500 mils, and prepared in exactly the same manner as routine sample. Table B24 did add additional requirements to aliquoting procedures, to the aliquoting procedures stated in 1633 to ensure homogeneity of some samples, specifically AFFF samples. Next slide. With respect to batch QC requirements, there are just a few differences from Table B15. Now there are 2 laboratory control samples, or LCSs, required to be extracted with each batch according to the method. One is at a mid-level concentration and the others at 2 times the stated limit of quantitation. The method does not require MS and MSD per batch. This is a general requirement for all analyses for the DoD. So this item was included in Table B24. And since the method does not specifically call it AFFF samples, the table also includes the requirement for a matrix duplicate for all AFFF samples. The method specifies the use of 24 extracted internal standards, or EISs. This has not changed from the previous Table B15, but the method also adds in 7 non-extracted internal standards, or NISs. This is a change. NISs were not required by Table B15. The NISs are spiked into the extract and are used to determine instrument performance and calculate the EIS recoveries. Next slide. With respect to sample analysis, there are some changes as well. EPA 1633 added the requirement for two more standards to be analyzed with samples. It requires a biosalt standard to be analyzed daily when tissues are analyzed. This is because biosalts are known to interfere with the quantitation of PFAS. Table B24 expanded this requirement to daily regardless of the matrix of the samples being analyzed. We made this change because there's been some research published that documents the detection of these biosalts in media types other than tissue. The method also requires daily analysis of quantitative standards containing isomeric mixtures of analytes when they are commercially available, excluding those that are included in the calibration standards. This is to help laboratories accurately identify branched isomers of PFAS. The method requires branched isomers to be included in the quantitation of an analyte in instances when a qualitative or a quantitative standard is commercially available only. If a standard is not available, the suspected branched isomers cannot be included in the quantitation. The method provides the ion masses that were monitored during the validation process. We have added a requirement to B24 for laboratories to monitor these exact masses in cases where branched isomers will be included in the quantitation of PFAS. This is because the method utilized the transitions that were the strongest, that had the strongest responses for these isomers. So we also added a requirement to the table for the recovery of the instrument sensitivity check, or ISC. This is because the method currently does not provide acceptance criteria for the ISC. It will when the method gets finalized, but currently it does not have any criteria. It has a recommended criteria, but not a hard, fast criteria. The calibration requirements of the method are also slightly different than that in Table B15. We also included in Table B24 a requirement for the analysis of a second source calibration check standard, the initial calibration verification, or ICV. While recommended by the method, it's not a requirement of the method. Since this is a general requirement for all analyses under the DoD ELAP program, we have included this in the table as well. Next slide, please. The method currently does not contain batch QC acceptance criteria, with the exception of the method blank, which defaults to the standard requirements for office of order methods, which is less than the MRL. Once the MLV study is complete, the method will be updated with QC acceptance criteria that is statistically derived from the study. That being said, we needed to provide everyone with some idea of what should be achievable by our laboratories. The limits we included in Table B24 were based on the results of the single lab validation study, recognizing that one lab can achieve may not be what all labs can achieve due to the differences in equipment, et cetera. So we widened the criteria a bit, and what we saw in the SLV study was that the lower end of the spectrum is what we needed to focus on. So these limits cover all analytes. Yes, a lot of analytes are capable of achieving much better. However, we had to set them at what was achievable for all. So this means the criteria provided in tables C44 and C45 with respect to laboratory control samples and MSMSDs does not apply to Table B24 or EPA 1633. Next slide. With respect to ion ratio criteria, we require laboratories to report below the limit of quantitation. So the option in the method to evaluate data below the limit of quantitation for ion ratio, which is not a requirement in the method, we made a requirement in Table B24. This criteria is slightly different than that of Table B15. The method also does not include EIS or NIS recovery criteria. These criteria will again be determined off of the statistical analysis performed on the multi-lab validation study results. So we obviously needed to provide some criteria, so we took a look again at the SLV study results and once again widened them a bit. I have to say that I really like isotope dilution external standard quantitation. Even when EIS recoveries were as low as 10%, we still achieved accurate quantitation in the SLV study, so that was awesome. That's why we're okay with setting the lower end of EIS recovery like we did. We chose 20%, not 10% as the cutoff because 20% criteria is what is typically used in most validation study guidelines. This criteria is different from that of Table B15, obviously, for EIS recoveries. And obviously, we didn't have any NIS recoveries in the old B15 because we didn't have NISs. So that's all new and improved. Those are some of the biggest differences you will notice in requirements when switching over to 1633. I'll tell you that it's our intent to update this table once the method is finalized. So that gives you hopefully a little more information on 1633 and our new requirements. Next slide. Switching gears, I want to talk about another method that has been recently published. This one is for the analysis of firefighting foam, DOD AFFF 01. Table B24 and EPA 1633 cover the analysis of AFFF concentrate or dilutions of a concentrate for the evaluation of 40 PFAS. This method has a different purpose. This method is applicable to the evaluation of AFFF concentrates for the sole purpose of determining conformance to the requirements of PFOA and PFAS content that will be stated in the next revision of the AFFF military specification, MIL PRF 243885. The method can quantitate PFOA and PFAS down to 25 ppb or less. It is very, very similar to 1633. Differences between the two methods are that this method includes requirements to ensure homogeneity of the subsample prepared for solid phase extraction. Single laboratory validation of the method determined these extra steps were needed for this difficult matrix type. The method also requires the preparation of each sample in duplicate to evaluate the homogeneity and the preparation of, and as also includes a requirement for the preparation of a laboratory control sample or LCS duplicate instead of an MS-MSD, like we are requiring for EPA 1633. This method is also available on the EDQW STENIX webpage. Next slide. Next, we have a method that's currently in development, not published, DOD F3001. This method will be applicable to fluorine-free foams or F3 concentrates for the determination of compliance to the Faker Mill spec for fluorine-free foams. It will determine total fluorine, so inorganic and organic fluorine, hopefully down to the current congressionally mandated limit for PFAS in fluorine-free formulations, which is 1 ppb per the FY20 National Defense Authorization Act. Sample preparation is done via hydrothermal alkaline treatment, or HALT, and activated alumina extraction. Analysis is performed by ion chromatography. We currently intend to publish the method as a draft following single lab validation and do plan to multi-lab laboratory validate the method as well in the future. Next slide, please. As far as other methods that are currently in development that will potentially be of interest to you in the future, there are a few. First, the DoD has funded through the CERTIP ESTCP a project designed to evaluate and optimize the current leaf methods for PFAS evaluation. If you're interested in hearing more about this method, the EDQW is hosting a webinar tomorrow that highlights some ESTCP projects that are focused on developing analytical methods. This project is one of those projects that will be presented. I believe Mary has just provided a link to the webinar registration in the chat box for everyone. If you're interested, you can still there's still time to register. The EPA also is developing non-targeted analysis methods for various media types, as well as total organic fluorine methods for a multitude of media types as well. There are other methods being worked on right now, but those methods these methods are the methods that are farthest along at this time. Next slide, please. I think that pretty much covers everything that I can cover with you today. I thank you for allowing me to steal some time out of your day, and I hope you find this information helpful in the future. Next slide. I believe we do have some time for questions, but if we run out of time or you want to reach out to me at a later date, you now have my contact information.
Okay, thank you, Janice. We have been collecting questions submitted throughout the presentation. Please feel free to submit any additional questions now through the chat. So a few questions here for you, Janice. Firstly, on slide 13, you mentioned there was one lab accredited for draft EPA method 1633. When do you expect additional labs to be accredited?
We have a rather large number of labs that are currently going through the evaluation process with the DoD ELAP accreditation bodies, and we expect more to follow very soon in the future. So we expect to have a couple of more laboratories be accredited very shortly, I'd say within the next month.
Okay. And when do you expect the multi-lab validation to be complete for draft EPA method 1633? That
is literally the $3 million+ question. It's my understanding that the method is going to be finalized most likely before the intent now, or the thought process now is that the method would be finalized before the multi-lab validation is completed in its entirety. So let me explain that. So the method, obviously, the primary focus of this method is wastewaters and surface waters, right? So those are the analyses that we are starting with in the multi-lab study. When all of that data gets generated and we do the analysis of that data, at that point, the thought process is we would be able to finalize the method, possibly even have the groundwaters also included in this analysis, but publish the finalized method relative to the aqueous samples before the soils and the sediments and the tissues and the biosolids analysis is complete. So the intent is to try to have a finalized version of the method with those matrices, all the data, the quality control criteria and everything for those matrices in the finalized method, hopefully by the end of this year. And then the other matrices to follow earlier next year, hopefully by the end of the first quarter of the calendar year.
Okay, and the follow-up to your response, would all the labs that are accredited be able to analyze all of the matrices that you list on slide 19? You mentioned that the biosolids and tissues may come later, but will all the labs accredited be able to analyze all?
Right. So, what the laboratories choose to seek accreditation for is up to them. So laboratories may only wish to play in the aqueous realm, or some people don't want to have to deal with tissue samples. So what a laboratory is accredited for, what matrices a laboratory is credited for, is dependent on the decisions made by the laboratory of what they're going to seek accreditation for, and also that same thing goes for the analytes. So the analyte list from laboratory to laboratory could vary significantly. And that's partly because they may, for instance, not be able to achieve they may have difficulty achieving some of the criteria that we put in the method, in the table for a specific matrix. The other thing is what you have to realize is that this method isn't finalized relative to the analyte list per matrix either. So when we go through the evaluation process of the multi-lab study results, we're going to take a hard look at that and see so for instance, let's say the FOCs, methyl and ethyl foci, don't behave well at all in tissue. We are getting really bad recoveries. If you look at the SLV study, it's obvious, right? So, we're going to take a hard look at that. EPA is going to take a very hard look at that and decide which analytes should be eliminated from the analyte list for each matrix. So there may be some that are not really applicable for this method for a particular matrix, and that decision is going to be made by the EPA and published in the final method. So, there's two parts. Down the line, the finalized method may not include all analytes for all matrices, but until that point, our laboratories, I expect that we are going to have varying analyte lists for some of the media types.
Okay, thank you. Sounds like there's more info to come as the months go by.
Oh, yeah. Absolutely.
So a couple more questions on 1633. I think this one says, when will the worksheet templates be available?
As soon as I can get them out there. I do have a draft of them. We are working towards those. We also obviously have to create method validation guidelines or data validation guidelines as well that are specific to Table B24, because those that are out there for Table B15 are not applicable. So we have a draft of those as well. So I'm hoping to get both of those items out by sometime early in the fall, I'd say. Hopefully sooner, but we'll see.
Okay, and the last question related to 1633. Are you aware of Elizabeth Denley and Kristen Morin's review of draft EPA Method 1633, a data user's perspective, that was recently published? If you are aware of it, did you have any opinion on it or Navy perspective on it?
I am aware of it. I have reviewed it. I really don't have a comment on it. You know, I think everyone's got to remember that we had no method, we clearly with the published method and everyone meeting the same requirements and doing everything in the same manner is going to allow for greater consistency from laboratory to laboratory. So yeah, I don't really have a lot of comments on it.
Okay, so switching gears a little bit, what about top assay or PIGGY methods? Can any of these be used as circular sites impacted with PFAS, maybe for screening?
So definitely not used for the collection of definitive data. You asked specifically for screening. There are limitations relating to both of those methods. Limitations for top assay is from laboratory to laboratory, you will get inconsistent results. The method is not a published, standardized, validated method. So, you know, that creates a lot of uncertainty from laboratory to laboratory and how exactly things are done. Also, the top assay has been applied to media that it was never intended to be applied to. And as a result, there are significant challenges associated with using top assay for a lot of various media type. PIGGY, there is one shop for that. It provides an estimate of total fluorine, but you know, screening, the value added on screening, I can see PIGGY potentially being used not necessarily for any kind of cleanup purposes or estimations, but more as a means to help ensure that you don't have breakthrough with your remediation techniques. It's a gauge to see when you're starting to see breakthrough and possibly need to change out your remediation media.
Okay, I think that's it for questions, so we'll wrap up now. So thanks to all of you who submitted questions, and Janice, thank you for your thoughtful answers and for sharing your knowledge of PFAS methods and how they are changing. If you happen to submit a question that we weren't able to get to, you can reach out to Janice directly at the email address that's shown on this slide. So next slide. So we are planning our next OER2 webinar for the summer on the use of an abbreviated accident prevention plan and lessons learned. Upcoming webinar topics are always announced via the T2 email. If you are not receiving our T2 email already, you can put a message in the chat box asking to be added to the list. Thank you all again for attending the OER2 webinar, and we look forward to having you back next time.